ETA to a beam, practice problem 4. Let's get going. ETA to a beam, practice problem 4. And just like the other 3, we're going to read the question and take down all of the information. So right away, we start reading. You are steering 019 true. Okay, that's our course. 019 degrees true. And a light is picked up dead ahead at a distance of 11.6 miles at 0216. Okay, so it gave us our first distance, and that was equal to 11.6 nautical miles. And it says we did that at 2:16. It gave us our time right there. 2 hours, 16 minutes. You change course to pass the light 3 miles off a beam to port. It gave us another distance. We're going to call this distance A for distance of beam, and that is 3 nautical miles to port. 3 nautical miles to port. If you're making 14 knots, what's your ETA? So it gave us our speed just now. It says we're making 14 nautical miles per every hour. What is your ETA at the position 3 miles off the light? It wants ETA. That's the question. What is our ETA at that light? Okay, so the first thing we do, we draw our triangle. Our course is 19. So 0 would be here, 45 is here, 19 is somewhere here. And we see this thing right there. So we're here, we see it here, we change course to leave this to port. So we change this way, right? That'll leave it off of our port side. And we leave it a beam, which means that's 90 degrees. And now we're given 2 distances. The first one, 11.6, right? That was from our original course to the light, 11.6 nautical miles. And then we're given 3 nautical miles of beam to port. Okay. And we're going to label these so we can put it into our formula. So we say A, B, and C. This is the longest side, the hypotenuse, across from this angle that was given. We'll always label it C. And I like to keep this one A, which means this one's B, and our formula stays the same the whole time. So A squared plus B squared equals C squared. That's the Pythagorean theorem. There's evidence that they use this formula in 2000 BC. That's old. These old guys can do it, you can do it too. So we adjust. We're solving for B, which means we need all the stuff over there. So minus A squared on both sides. So B squared is equal to C squared minus A squared. And then we put our numbers in. What was C? 11.6. 11.6 squared minus, what's A? 3. 3 squared. Okay, let's get our calculator. 11.6 squared equals 134.56. 134.56 minus 9. I'm going to punch that in. We just hit minus 9 equals 125.56 equals 125.56. So B squared is equal to 125.56. To get this square out of here and just get B, we take the square root of both sides. So B equals the square root of 125.56. What's that give us? Conveniently, it's already on our calculator. So here's a little trick. It's right there. We say That's our answer, right? So we say second square root, and then we could say second of the answer that was on our calculator just now equals 11.21. See that 0.205? That 5 rounds up, and I'm using 2 decimal places. So 11.21. 11.21. Good. So B is going to be equal to 11.21 nautical miles. Good. Now that we have this distance, we were given a speed, we can find how long this took. So distance, speed, time. What was our distance? Our distance was 11.21. 11.21 nautical miles. Our speed, 14 nautical miles an hour. 14 nautical miles per every hour. What was our distance? If we do our little memory aid, D Street, time is distance over speed. Distance divided by speed. What's our distance? 11.21. 11.21 nautical miles divided by 14 nautical miles per hour. These nautical miles cancel off. We'll be left with hours. 11.21 divided by 14. It's going to be less than 1. And what's cool is it's already on the calculator. Boom. So this is even more accurate because we just go divided by 14 equals 0.8. All right. 0.8 what? 0.8 hours. So we get 0.8 hours. We need to get these hours to minutes because we want to add it here, right? If we are looking like, we can't add it to just hours because that would look super weird and not give us the right answer. So this needs to be in minutes. So 60 minutes per every 1 hour. These hours cancel. You're left with minutes. And what does that look like? We know 0.75 would be 45 minutes. So we're going to be just above that, right? Okay, it's already on our calculator. We just go times 60 equals 48.02. 48 minutes. Alrighty. That's good. That's looking good. 48 minutes. We can add 48 minutes to here. So 2 hours and 16 minutes plus 48 minutes is what? So 8 plus 6 is 12, 13, 14 plus 1. So we got 4, 5, 6. So now we have 264. Well, we can't have 64 minutes, right? So we're going to take 60 out of here, add an hour over here, and we'll get 04 and 304 is what we got for our ETA. Let's see our answers. Hey, look at that. I even have a nice tick mark on my thumb for you. B. 0304. That's what we got. 0304. Let's double check. 4 is B. Boom. That's right. We got it. So we got the right answer for ETA to Abeam practice problem 4. On to 5. If you got this far, good work. Stay at it. We're on to 5, and then there'll be 2 that you get to solve yourself.